So at this point, we've gone through how to name and write formulas for a few of the different kinds of ionic compounds, and I wanted to introduce something that's a little bit different, and that is the idea that some elements actually have more than one charge. And I think a really good way to look at this is if you take out your periodic table, and we're going to take a look in the middle section of your periodic table. So let's jump to that, and let's see what I'm talking about. What I'm talking about is this part right here. So we're basically looking from element 21 to element 30, all the way down to 112 across to about here. This is what we would call the transition metals, and it's just a section on the periodic table, but I'm going to zoom in on one of those transition metals in particular, and we're going to look at iron. So just bear with me while I zoom in and readjust my camera so that we can see it. And if we're looking, actually you can pick almost anything out of here and look at the numbers in the top right corner. Up until this point, we've only really dealt with things that had a single number in the top right corner of their box. But look, chromium has +3, +2. Manganese has +2, +4. Iron has +3, +2. These are what we call multivalent metals, meaning multiple charges. So they have different ways that they can use their electrons to gain or lose, or really in this case, lose their electrons. And what I wanted to show you is how do we deal with naming in a way that shows us what that actually looks like. Whenever we're writing names of compounds, there should only be one name that you can use to tell somebody what that substance is. So I just want to draw a formula here for a second. Let's say I wrote like Fe2O3. And you told me the name was iron oxide. Right? That's following the rules I've showed you so far. You wrote the metal's name, you wrote the non-metal's name afterwards, and then you changed the ending to IDE. But if I were to go to my periodic table, how do I know if this is supposed to be a 3 or if this is supposed to be a 2? So what we should actually be doing when it comes to writing these names is we want to make sure that we write the name so that people know what charge this is supposed to have. So let's think for a second. Let's kind of backtrack. Remember, we've been swapping and dropping? Let's unswap, undrop. We know that oxygen would have had to have a -2, and if that's the case, this iron had to have a charge of +3. So the way that I'm actually going to write my name for this compound is I'm going to tell people this was iron with a charge of 3. So I'm going to put brackets, and then I'm going to use the Roman numeral for 3. And then I'm going to write oxide. This is how I now know what charge it has. So when it comes to substances like iron that has more than one charge, or cobalt, or nickel, or really pretty much anything that's a transition metal or that has more than one charge, you need to make sure that its name contains Roman numerals. And those Roman numerals represent the charge of the metal. So that is what they are for, the charge of the metal. So let's do another example. What if I were to say FeO? How is that any different from that? Well, let's think about those charges. We know from the periodic table that oxygen only has one charge. It has a -2. And if there's one oxygen and one iron, that iron had to have the same charge, but positive instead. So if I wanted to write the name for this compound, I would have to write iron 2 oxide. And that's the way that we end up dealing with these things. Now, that's how we write the names, is you have to look at the substance, kind of backtrack the swap and drop, figure out your charges, and write them as Roman numerals. But what if you were given the name? How do you turn that into the formula? So let me just erase really quick here. It's going to be a real mess for a moment. Okay, so what we're going to do is take a look at an example that has just our name, and then we're going to turn it into the actual formula. So let's start with copper 1, let's say sulfide. What is that going to look like as a compound? Well, copper 1 means copper, Cu, with a positive 1 charge. And sulfide, IDE, so that's a monoatomic ion from your periodic table, has a -2. So now we need to do our swap and drop. So the 2 is going to go with the copper. 1 is going to go with the sulfur. We get Cu2S. So that's our formula when we're dealing with this. Let's try something a little bit different. Let's say we go with palladium 2 nitrate. So palladium, go to your periodic table, you're going to find that it is Pd. This means a charge of +2. Nitrate ends with ATE, so that's going to be NO3. You know it's got to be polyatomic. It's got a -1 charge. Swap and drop. 1 PD, 2 NO3s. So remember, we need to write that NO3 in brackets with the 2 on the outside to show that we have something a little bit different, so that we have 2 of those nitrates. So hopefully that makes sense. Let's do one more example. Over on the side here, we'll try something a little bit more challenging. So what if I were to say something like molybdenum 6 phosphate. Okay, so now we need to figure out what this is. Molybdenum is MO. 6 means it has a +6 charge. And phosphate ends with ATE, so that's got to be a polyatomic, and it is PO4 with a -3 charge. So let's swap and drop this. You end up getting MO3, and I'm going to need 6 phosphates. So bracket PO4 bracket 6. Now, I'm not done yet because you notice I have a 3 and I have a 6. I can reduce this so it becomes MOPO4 2. And that's how we end up working with these. Remember, I had to reduce it to the lowest term, so I divided each one by 3. That's how I got to this value here. As you work your way through naming and writing formulas for ionic compounds, it's really important that you kind of recognize these different situations. So first of all, look and see, is it ionic? Do you have a polyatomic ion, or is there a metal? Those are the 2 clues that tell you you're dealing with something ionic. Naming is pretty straightforward. Use the Roman numerals if it can take more than 1 charge. Make sure that you write the metal first. The negative part, if it's a single ion, a single atom, make sure you change the ending to IDE. There's a few different rules when it comes to actually writing the formulas. So remember, brackets around multiple polyatomic ions swap and drop and reduce any possible numbers of ions to their lowest terms that you possibly can. That's how we deal with ionic compounds. And hopefully you'll stick with me as we move on to the next type of naming and formulas, which is called covalent. So that's going to be what we look at next. So thanks for watching.